Hi there. In this course, you are expected to find papers yourself that you have to use, that you have to present, etc. So I thought it'd be useful for you to, for us to have a little lecture on how to find papers of relevance and how to cite them as well when you're writing the report. So, and how you should cite. You might think that it's sort of very easy to just use Google Scholar and then you, or Google even, and you find all the papers you want. That works, but there are sometimes a bit hard to find exactly what you need or what really exists there. So I will present some strategies that could help you to more easily pinpoint and identify relevant papers. So you might ask, well, Frode, do we need to have citations to and references in our reports? And the answer is, well, you don't need it, but it's highly encouraged, because if you include references and citations to those, you're really showing that you know more, that you've done more work, that you familiarize yourself with the research discourse. So this is highly encouraged. And there are also good reasons for doing so. One of the motivations for citing other works and having references is to gain support for your claims and perhaps your ideas, and to establish trust in your work, so the reader will trust what you are writing. So what we do is that we, instead of saying that this is, I claim such and such, then you can refer to other people to gain support for the claim. So since they said it, then it's probably more true than if only you said it. And then the reader, when they see that it's not only your ideas, but also the ideas of others, then they think, yeah, this is probably more likely. So then they will trust you, or more likely to trust you. There's no guarantee that they will, of course. So look at this claim here, relevant to the course. AI makes GUIs better. That could be a claim, that if we use artificial intelligence, graphical user interfaces might be better. That could be a claim. If you just take this claim and listen to it, you might think, that's a bit strange claim, because I think it's a strange claim and I don't think I agree with it. And a natural reaction to this is this really true? You know, and it's quite natural for the reader to be skeptical of what they read. And you, as when you're a student, you should also be skeptical of various claims and question: is it true? Who did say this? You know, so we need to provide some evidence if we have some claims that are hard to swallow. And if you are making a claim and you can't find a reference to support it, maybe you need to reconsider your claim. So this is also healthy, you know, in terms of qualifying. Quality assuring your text. If you're making claims and you're unable to support your claims, then maybe you need to reconsider what you wrote as well. And yes, the second motivation for including citations and references is also the process of putting your ideas and your work into a existing research discourse. That means that you can show that the ideas you're presenting are building on other works that already is there, and that it's not been repeated, that it's not been done before, but it's a nice little extension of what other people have done. And you might also get inspiration for tuning your ideas. We start with some ideas, but then we have no idea what other people have done. So if you look at what these people have done, we can sort of retune our own, that was done, but maybe if I do slightly different, I can do something else. So things you might want to answer by doing the literature search could be, is my idea new? Is it novel? And is it original? And sometimes the answer could be no. It could be also yes, but most likely it's likely to be, yeah, there is some novelty here, you know. And then you need to sort of be, by looking at other people's work, you'll be able to answer that and know exactly the nuances there. And you can should ask yourself, had this been done before? And the answer often is also, yes, it has been done before, but not exactly the way you thought about doing it. So even if something has been done before, it doesn't mean that something is not new or novel. But you need to look at it so you can assess that. And sometimes it's also good to repeat things that have been done. You need to identify if it was done before, who did it, and how did they do it? Okay, because then you can look at why it's different from your ideas, and what did they find out? And what you find out is important because that can help you also to figure out what you should be finding out through your study, not only what you want to do, but also what you want to find out. It should actually be driven. Research should be driven by what you want to find out, not necessarily what you want to do. What you want to do is a means to an end of finding out something. And based on all of this, you might want to adjust your idea or what you want to do. So that's the second motivation for looking into references. Note that if you are unable to find any papers related to the things you are searching for, your ideas, that is not necessarily evidence that this work doesn't exist or haven't been done before. It's only evidence that you didn't find it. So it could be that it exists. So just be aware of that. Absence of something is no evidence that it doesn't exist. So what should we actually trust? There are different kinds of sources, and we need to understand the different categories of sources so we know what weight to put into this. And experienced researchers will have this in their blood, so they know what to trust and not to trust. And we can divide things into probably more than three, but I would say three main categories, and there might be more, of course. And the first category is, and that is primarily what you will be looking for, are so-called peer-reviewed sources. This means that these are typically papers that have been assessed by other researchers. They have been criticized and checked thoroughly before they've been published, so that you know that someone have looked at it. That doesn't necessarily mean there are no mistakes or that there are no problems, but it's less likely to be complete sort of rubbish in the papers. And you can assume that most conference papers, proceedings from conferences in computer sciences, have been peer-reviewed. Journal articles typically have been peer-reviewed, and certain types of books, but not all books. Only so-called books that are anthologies. These are specific academic books in chapters, and then it will usually say that it has been peer-reviewed, and it might be monographs. In computer science, monographs are not very common, so you don't probably have to worry about that. That's more within other fields, such as social science, where they write long books on a single topic. The second group of sources are what I would say non-peer-reviewed sources. And this is what you have to watch out for. And this is what students typically cite, and especially bachelor students, but also some master students. And this is what makes examiners say, not good at all. And this includes things like textbooks, like Introduction to Java Programming is a textbook. It's maybe an academic work, you could say, but it's not a peer-reviewed source. So very few of the books you had as a bachelor student have been peer-reviewed. They have been quality assured, they have checked the language, etc., but not the content. So they are not reliable sources. Another thing that people tend to cite a lot are websites. Websites are not peer-reviewed usually, so be careful with websites. And another thing are popular magazines, things made for the general not very detailed technical articles. They usually, if it's peer-reviewed, it will say so in the beginning somewhere. And what I want to communicate here is that it's not illegal to cite non-peer-reviewed sources such as web pages or textbooks. You may do so, but you shouldn't only do so. You can have a few to sprinkle up your thing, but you should mostly base it on peer-reviewed sources and use non-peer-reviewed sources sparingly. For instance, if you are making some system and you are used some framework and maybe something from apache.org or something on GitHub, it might be relevant to provide a reference to sort of say, I used a data set from this website, or I used code from that website, because the reader will then know, oh yeah, it's the source of some information. So it doesn't have to be peer reviewed. We know it's just some code stuff. So it's be careful and know that difference. The third group, this is, I would say, sources of impact, and these are typically renowned organizations with a lot of weight. And here I'm thinking about the World Health Organization, the WHO. It could be the United Nations, or it could be a government like the Norwegian government. And when they releases official statistics, white papers, etc., these are not peer reviewed necessarily in the same sense as an academic paper, but they probably gone through a quality assurance process and maybe also peer reviewed in some way. But at least it's some quality, and we can usually trust numbers from big organizations like this. Not necessarily always, but usually. So it's good to, when you're referring to facts, figures, and numbers, it's very useful to refer to such renowned sources. And if you're talking about accessibility, for instance, and disability, it's very common to cite the statistics from the World Health Organization that say X number of people around the world are blah, 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 etc. So that's useful. So here, to get support for your claim, try to stick to the peer-reviewed sources and these renowned organizations. Say that I want to find a paper relating to getting suggestions when entering text on smartphones. Now, if I have no clue about how to go about this, I would typically start with a wide search, and I typically then will start with Google Scholar. It's sort of a very broad engine that I think most of you are familiar with. So let me try that. Say text suggestions smartphone. Actually, yeah, text input maybe I can write here as well, because this of course is linked to both write correctly. Input is related to both artificial intelligence and user interfaces. Okay, let's see what happens. Okay, here this is a person I know. Okay, text input on the smartwatch. Oh, that could be interesting. So here we see I already get several suggestions. And at least this is a good starting point where I can now start to explore these in more detail. Say I have some search result and I want to find the full text paper. Well, if I go into some of these, follow some of these links, I might be lucky and find the full text paper. For instance, here I'm in IEEE Explorer and find this paper, text input on the smartwatch. So there's a link here, PDF link, and I can click on it. And if I wait a bit, download takes a bit of time. I see I get this thing here, and that's fine. And that sometimes that is occasionally you can be lucky and find some of these papers. Let's go into the first one here. And if we now look here, we can see that there are no PDF links, but there are buy ebook and buy paper. So what do you do then? Well, you don't have to buy the paper to download it. Actually, we at OsloMet have the subscriptions, so I will just show you how you can get through that. And I assume you will be sitting at home. So what we do then, you go to easyproxy.oslomet.no like that. And then you get the login screen like this. And here you log in with your regular login credentials. like that. Let's see if I have entered my correct credentials, and then I get in here, and then you can see that there is a long list of items. Now, what you usually will need is ACM. So then I will do search here, Control F, and then I do ACM, and then I find the ACM database here. Now, what we saw previously was that this was in Springer. So if I want to find this paper, I need to go to Springer. So let's see if I can find that. Springer link and Springer publishing. Here I actually happens to know it's Springer link. And if I want to find the full text paper here, I can simply copy the title and I can enter it into the search box here, and voila, here I get it, and here I get to download the PDF, and then I can see the full paper. So if we go back here, there's a couple of these you might be interesting. Is ACM, I showed you Springer link, and we also have the IEEE Explore, which was the other one here that you can find here. Then you have the access to all the IEEE papers. This is very useful. Say that I found too many results when I was searching with Google Scholar. I cannot find the full text. I can search Google Scholar, but I get too many results, and I would like to have a bit more narrow scope. So what I do then is that I go to ACM again, see if I can do that. Oops. ACM, and say I want to, here we are in ACM Digital Library, and I want to find papers related to this text entry suggestions, but I only want to search in the International Conference on Intelligent User Interfaces. So what I do then, I go to Proceedings, and then I go to I for IU. So here I can help myself maybe by, I can try and type that in, IUI. Yeah, here we go. Intelligent User Interfaces. And then I can click on, say, the last one here. And then we see I have the search box here, search within UIU. So if I now want to search just within this conference, I can enter here, for instance, text input suggestion, and let's see if I get some more specific hits here. Oh, okay, I got a lot of suggestions here. So here we have 1800 results relating, including all of these three. And ACM tend to give us the prioritized list here. So here we have the abbreviated text input as a suggested models for geographic exploratory search. That didn't seem relevant, but let's have a look at this one. And then you can explore the results. So this is just an example of narrow search. To search using keywords means that you know what the keywords are. You need to know what you're looking for. And that's a problem when you start off to do research into a topic and want to find papers. Another approach which I find useful to combine with this is to do a bottom-up approach called eyeballing, where I kind of have an idea what I'm looking for, but I don't know how to articulate it necessarily. So that means browsing venues that are interesting. So say that I'm looking for something interesting or related maybe to this text thing in this venue called Intelligent User Interfaces that we looked at and which we have used a lot and will be using in the course. So what I do then, I just go into that conference, and eyeballing is simply just browsing the table of contents. So let me go, and what I might be interested in the most recent one. So we have the this one. There are two IOI 20. There is a normal one here, and then we have a companion. So the normal one seems to be the one that's more reputable, I would think. I'm not sure what companion is here, but I think it's a companion proceedings. Let's try this. So I go in here, and then we get to see the proceedings, and here, the research article, and here I get a list. Oh, here I get the pop-up, annoying pop-ups. Okay, here we have different sessions. So here I can just go into these different sessions and explore it. So let's start with intelligent support. So then I can browse here, I can say understanding, blah, 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 towards making, vision, nah, not really, a gaze, no, blah, blah, blah. Okay, let me try and do active and interactive machine learning. Let's see if there's something interesting here. No, Word, what does it say here? Word recommendation to obtain diverse crowd search but phrases of user utterances now. Investigating audio now. Deep. Okay. So what you have to do when you do the eyeballing is that this can take a bit of time because you have to kind of look at things and spot and think. And if you're curious about some of these things, you can just go and look at it and explore it in more detail. So it takes time. It doesn't take too long if you go through this. It takes a few hours. It can be a bit fun, and you might discover something that you did not intend to look at. But that's okay to do a bit of departure. And I think it's good to do both techniques. You both do the top-down approach by using keyword searches, but also the bottom-up eyeballing, because you will find different things, and you will come across some other things that you didn't think you would. So that's eyeballing. Now, let's say I have found this paper that I find interesting, and I want to, then I can use this paper to help me refine my search. So now I have the predictive text entry or text entry suggestions, I think. And the first thing I look then is to sort of see any other interesting keywords here. And if I look at the author keywords, we see here we have interfaces, we have predictive interfaces. Maybe I could use predictive text entry as a search term. And here, mobile text entry seems to be another term as well. So then I would go back to Google Scholar and I would try these terms out and see if I found something else. I would also scan the abstract and I would scan the introduction just by briefly reading and see if I find anything interesting words that they use to describe this field I am trying to get into. And another thing I would do is to look at the background section where they describe related works. So here it's called background. Sometimes it's called related works, but here you will find the references to previous works. So here they talk about touch sensitive, stylus, digitizer, and we just scan the things here. Augmentative and alternative communication. That certainly is something I would search for. This is the field of making assistive technologies for certain users. Let's see. Yeah. So this you would do, and that would just looking at the text. I would also go back to the references, which in the back of the paper you find here always at the back of the paper. You'll find reference section, and here I would scan the titles of each and every one of these papers to see if there's anything that seems interesting. And this is a bit like a time machine, because here we see what this researcher used in order to make this paper, what research does he base this on. So it's going even back in time. So that's very useful. I will show you another little trick that you could do as well is to, here it could be that these papers, these authors are making other interesting related stuff. Now I happen to recognize this name, Zhu Minzai, so I know that he is actually very active in this field. Could try the other one as well, but now we'll just do that since I know that this is a reasonably famous person. So I go into Google Scholar and I can enter his name, and here's a trajectory-based tasks pointing touch screen interaction, and we can see dictionary from input devices, pen-based computers, shorthand writing for stylus keyboard. So you see here he's sort of doing some text and input. We can do, maybe add to the search time here, we can do the text input like this. Whoops. So here we see text input suggestion ranking. Okay, this here we get another paper that seems relevant to what we're interested in. And this is not the paper. It's very interesting. It has a patent. But I'm not interested in paper patents, so I can exclude that from the search. I didn't write it correctly. We have to do it correctly here. Whoops. Input. Maybe we can write suggestion. Oh, this is that one. A memory keyboard based text input method. Okay. So by continuing here, we can see if we find, also by looking at who the authors are. Oh yes, what we could do, we could even use normal Google, and we can see if we find this person's webpage. Zoom inside, straight on. And here we see this is that guy, I think, and there's a picture of a keyboard. Very interesting. We can go to the publications, and then we can say, and here we can then find another source of starting to do this detective work of finding papers. In the previous example, we looked at how we can study a particular paper and find better search term and find also interesting papers based on who wrote it and the references. And when we look at the references here at the back, we go backwards in time. But what if I want to say, ask the question, did this paper, was this useful to other researchers? Has this been used afterwards? Is this in some way been influential, and what are people doing now? And that we can do by looking at citations. Then we can go forwards in time. And if I see this paper, if we go to Google Scholar again, which I hear, and here I have this paper. It's the same paper that we found earlier in my search for text input suggestions smartphone. I can see here that it says cited by 34, and this will tell me that there are people who have cited this work. So then I can look at that and see who have cited this work. So here we have typing on an invisible keyboard. That's interesting. On suggesting phrases versus predicting words for mobile text entry. Okay, that's interesting. This one is done a bit later, 2016. Okay, so now I could look at that in more detail. I can see who's worked on that. This again is cited by 23 people. Okay, I click here. Learning private neural language modeling with attention suggestion. This is in 2019. And here we have a quick view, a novel data-driven mobile interface for reporting problematic feature. Okay, smart handwriting on watches. Is there anything interesting here? Wise type, color code visualization, or any options for error correction. That could be interesting. 2019. So we now find stuff that's based on this previous paper. Oh yeah, here is something interesting. Sentiment bias in predictive text recommendations results based in biased writing. And that we see is, now I'm loading it in. This is from 2018. So now I went into the future, like with a time machine. So following the references at the back of the paper, we go backwards, looking at citations in tools such as Google Scholar, or Google Scholar in particular. We go forward in time. And this is also a very useful tool for finding related work and kind of finding all the pieces in the big puzzle. I have some good news for you. You might think, oh, Frode has asked us to read all these papers. It's so much work. It takes me a whole day to read a paper, you might say. So the good news is that there is a technique for reading papers. And the good news is that you don't have to read the whole paper necessarily. Only if it's very interesting and very relevant, you need to read the full paper from beginning to end. But generally you don't. And the more experienced you get, the less you have to read, because you can recognize things, recognize patterns and things. So when you're more experienced, you probably have to read more. The more experience you gain, the less you have to read of each paper to get an overview of what this is all about. So the thing here is to be greedy. So the rule here is to first get an overview of what this is all about, and then focus on the details later. Overview first, details later. So because if the overview tells you that that this is not the right direction, you don't have to waste time on the details. So that will help you to sift through things quickly and eliminate things that are irrelevant. And one advice I have to you, that sometimes you come across a paper and you think it's so hard to read. I don't understand this paper. If you sit with this feeling that you probably should have read this paper, but you don't understand it, just ignore it. Discard the paper, throw it away, and read something else instead. Because if you don't understand the paper and spend a lot of time on it, you're not going to get much joy out of it. And there are indeed a lot of academic papers that are very poorly written and hard to understand. So don't waste time on them. There are so many other papers to read that are understandable. So let's focus on those fun and engaging papers. When you read the paper, after you get the overview, you can focus on a specific thing you're interested in. So you could be looking at, for instance, only the references because you want to see what other work, we know that from the title, say that this researcher is working on a specific topic, and you wonder, so what was the basis behind this work? So you might want to look at the related work section, say, they did blah, 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 and see what they cited. So you can see what was the history behind it. So you can see from the paper going back in time. You might want to focus on the specific method. How did they study this? So then you want to read the methods section in more detail. Or you might be interested in comparing results. So then you might jump straight to the results section. If we are trying to refine our keyword searches, you might just look at the keywords and maybe the abstract. I typically tend to kind of browse the abstract, and I tend to go straight to the conclusion and look at, what was the takeaway message. That should also be in the abstract, actually. So if I find all the things I'm looking for in the abstract, I'm happy. The difference between a novel and an academic paper, of course, is that in a good academic paper, we will reveal the murderer on the first page. We will reveal who is committed a crime, so to speak, whilst in the novel they hide the goodie at the last page. You have to read through the whole novel and then you find out who was the murderer at the last page. The style of academic writing is that you know it from the beginning. Okay, imagine now we have found some papers we are interested in and we want to put them into our report in the reference section. So how do you do that in an effective way? You can, for instance, use EndNote or BibTeX or some tool like that, but it's very complicated. If you're having a reference with a report with, say, 10 or up to 30 references, it's a much quicker way to do it, especially if we're using APA citations. And this is something I learned from a student, so I will show you this trick. Say that we want to put this paper we already looked at by Chen-Min Tsai, this cost of benefit study of text entry support interaction, and I want to put that into my report. Then all I have to do is to click on this symbol here, the quotation mark. And when I click on that, I get this list. So I can choose here between different citation formats, which are formatted correctly for me. Now I have recommended that you use APA, so that will be the second one. So I can click on that, simply copy it, and then I can open Word. And I have to wait for Word to open, have it document. I have a blank document now, and then I simply paste it. And to get rid of the formatting, it's just like that. And that's how simple it is. and the formatting is correct. You get all the information, and you will not hear any complaints from me, or if you do this in other courses, you will not hear any complaints there either. Let me just do the other one here. We can, this is the first one, first on the list. I just do the same thing, copying it, pasting it in here, and there you go. And then I can get rid of the formatting. The shortcut key I used to get rid of formatting was, after I pasted it, was Control T. It's a very not intuitive command. Often students tend to cite papers a bit uncritically, so I thought it's worthwhile to spend a little bit of time to talk about citing works. So let's do that. Look at this claim that we have with a reference. So here we have a claim, and it's been supported with a reference. So here we say AI makes GUIs better. You know, artificial intelligence makes graphical user interfaces better. This is the claim that we saw earlier, which I thought was a bit strange. I don't really believe it. But okay, here we have found a reference to somebody who says this. So here's Ignoramus 2019. This is a fictitious reference I made, of course, because I still believe this is a nonsense claim. But now we will look at how it's written. Now, what I'm interested in here is not so much the claim, but I'm interested in how the claim is phrased. And if you look at this, say that you wrote this claim, then you're actually saying that this is a fact. You are saying that this author, this Ignoramus, did say this, and you agree with it because it's a fact. You're stating this as a fact. AI makes GUIs better. Full stop. No one can disagree with that. That's what the claim is saying. That's very dangerous. So how should you do it? Well, my recommendation is not to make such bold claims unless you really mean it. And instead you should kind of don't necessarily agree with the source, the person who kind of came up with the claim, but you can kind of be the reporter where you stand on the side and you say this went on there and just describe what happens. And I have two examples there on how you can phrase this. So the same claim that we saw on the previous page. So let's look at this. According to Ignoramus 2019, AI makes GUIs better. Or alternatively here, it is claimed that AI makes GUIs better, and then it's referring to Ignoramus 2019. If we look at these compared to the previous claim, is that here we see that according to, so we are pushing the responsibility to Mr. Ignoramus here that AI is better than GUIs. We are not necessarily agreeing with it. We're just saying this guy did say this. You know, that has been claimed, but I don't reveal my opinion about it. And that means that the reader can say, oh yeah, this person found a reference to that. Okay, I think that was a stupid claim, but okay, somebody said that. It's easier to accept when somebody describing what was reported by somebody else than actually promoting the claim themselves. So this would be a recommended approach in these situations. And I think then the reader will also trust your writing more, because they will see that you are more an objective writer. You're not taking the side necessarily of the person who wrote the original claim. So I think then they will trust your text more. So I thought I'd summarize the strategies that we have for finding good sources. So we will always start when we know nothing. We will start an initial search based on the few keywords that we could think of, and we will get a few results, maybe not so accurate. Then what we do is to inspect these results, and we try to spot references to other interesting works in the reference sections in these papers. Then we read those other papers that we think are relevant. And then we are kind of traveling into the past. So it's a time travel, like a time machine into the past. And then after having done that, we will have found more fitting search terms through reading these papers. We will know how the researchers are describing the various things that we are wanting to look into and do research on. And then we can also, this I haven't actually mentioned thus far, but you can actually also Google the person that you find in papers and see, did they write any other papers? Maybe some of the other works they have written is related to this and might be interesting. Maybe they have a web page with their papers on. So that could be a very good idea for doing this detective work, for uncovering all the available papers. You should also use the tools like Google Scholar to see who has cited those works you have identified, those papers you identified. And then you can look at those papers who cited the paper you found and look at them. And then you're doing a time travel into the future. You kind of, fast forwarding into the future to see what went on now. And that can also shed light on uncovering the most recent developments. And then you will have discovered even more references and more keywords. And then over time, when you do this in several cycles, you will then gain a deeper insight into the topic, into the field. You become more mature and you have learned a lot. And so I would say that this is a process that takes time. A final note is that research is not something that stands still. It's a living organism that moves with time. So every day, thousands and thousands of new research articles are being deposited in various digital libraries around the world. So if you did a search yesterday, you might find something different today because there might have been new papers added. So if you're working on a project over time, it might be worthwhile to repeat some of the searches a bit later on, a month later or 6 months later, because then you might find even newer stuff that have emerged. Where should we find our sources? We have already looked at Google Scholar and ACM, but there are other ones. I would classify these into, I use the term metadatabases and full text databases. A metadatabase is a database that will only tell you that the paper exists and what the title is, the abstract, the authors, etc. about the paper, but it will actually not contain the paper itself. And examples of that is Google Scholar. Google Scholar is a metadatabase. It only contains information about the name of the title of the paper, which type the paper is cited, another paper, etc. But the database itself only provides links to the paper, to the full text of the databases. Other ones that exist are Scopus and Web of Knowledge as well. These are paid for professional databases. They have a narrower scope, and I don't think you will need to use them, but I'm mentioning them for completeness. You probably Google Scholar will be suitable for all your work as a master student at OsloMet, I think, for meta searches and citation searches. You actually get more hits or more citations with Google Scholar than with the other ones as well. But if you want to explore Scopus and Web of Knowledge, you can find them because OsloMet is subscribing to these databases as well. Now, when it comes to full text databases, where you actually find the full text papers, you probably have to use a subscription service. And fortunately, OsloMet have a subscription service we subscribe to most of these, to many thousands and thousands of journals and different publishers as well. There is a long list within computer science, and specifically related to this course. You probably don't need very much. I think you can find 80 or 90% of all the most relevant papers in ACM Digital Library that we already have looked at. But you might also want to go into the IEEE Explore database because they have a bit more technical approach, and you will find a lot of AI papers within IEEE Explore. not so much on users, but something on users. So there might be some relevant sources there. ACM Digital Library is more user-centric, but also the technology. And in addition to ACM and IEEE Explorer, you have a Springer link. There you will, they have, they are the ones who are behind the famous lecture notes on computer science, which carries loads of the conference proceedings around the world. So that might be worth a search, in addition to having many journals. And the same is Elsevier's Science Direct. If you just use Google sitting at home without using any of this, then you might be lucky to find some of these papers through self-deposited papers that people publish in ResearchGate or whatnot, or open access papers. But if you only rely on those open things, then you might miss some really good stuff. So I really encourage you to use the full text databases because you do have access to it. So please use it, because your quality of what you find will be better than just simply using Google alone. Okay, we have come to an end. I hope this was useful. I hope that you now have some more systematic approach to your literature search, and that this will help you to identify papers that will be useful for your presentations and for your project and whatever, and also for the future when you're going to work on your main dissertation, etc. So with all this said, good luck, and I'll see you next time.